So today we'll talk about scaling service operation at the edge through centrally managed orchestration. I'll start with explaining what I mean with edge. And then I'll go into the operations model that we deal with in edge, which challenges we faced while dealing with these two operations model, dealing with service operations. And I'll explain how managed pipeline templates helped us overcome these challenges. And finally, I'll sum it up by talking about the learnings from our journey. But first, a little bit about myself. Let me introduce myself briefly. My name is Ludovic Galibert. You can call me Ludo. It's usually easier to pronounce and to retain. This is my professional picture. If you look me up on Slack, I actually look more like this. So any scuba diver in the room? Ah, yes, a few. Cool. For those who didn't raise their hand, you should definitely try it out. It's awesome. So I've been 4 years at Netflix, although I actually cheated. Technically, it will be at the end of this week. And I work on the Edge developer productivity team. So we write tools and services for other engineers at Netflix in Edge and client teams to enable them to innovate, move fast, and yet not break things. So we want to provide them a rapid, scalable way to move their ideas from concept to production and operate them with minimal overhead. So you've heard this Edge word twice already. So what is that? Edge stands for Edge Engineering. Edge Engineering encompasses the services from Netflix that are the front line to the Netflix ecosystem. We operate the majority of mission-critical Tier 1 services responsible for the sign-up, discovery, and playback experiences. This is an overview of the Edge architecture. So you have billions of requests from devices every day, going to Zuul, being funneled down to the microservices that we own. And if any of these services go down, we don't have a fallback. If any of these services is broken, then your Netflix experience is broken. You might not be able to sign up for the service or look for titles. And the worst case is you will not be able to play back a title, which would be horrible with that weather outside if you couldn't stream Netflix. So a little bit about Netflix. We're now in over 190 markets. We have over 130 million global members. And the number of members keeps growing. As you can see from the last few years, we have a steady growth of users. And these are typically the numbers that you see when we're talking about Netflix. But what about micro or nano services growth? Our engineers keep improving our systems, making them more resilient, adding features, and all of that to provide the best experience possible to our members. And that entails creating services over time, more and more services. And that looks more like this. The team size are growing sublinearly to the number of services that they're operating. Just as an example, in Edge, we have so many services that we now have, in average, about 1.5 engineers per service. It's not a lot. So what are the operations models we have in Edge Engineering? We have two operations models, mostly the full cycle developers, which Greg talked about this morning. And if you didn't get a chance to attend his talk, you might have another chance at QCon SF in November, or you can read the blog post online on the Netflix Tech blog. So this is a prevalent model in Edge, but we also have another operations model, which we call Centralized Operations. So I'll talk a little bit about this later. For full cycle developers, the motto is operate what you build. It's mostly for server engineers. So the Edge engineers develop those mission-critical services, and they move them all along to production. So they don't just develop code, but they are responsible for everything. They manage the orchestration that they need for their service. They manage the infrastructure. They need to make sure that their service is provisioned sufficiently to handle production traffic. So in the end, they're responsible for the whole software development lifecycle. And on the other side, we have centralized operations. So this is a bit of a special case with an edge. And this is related to the fact that we provide a platform that is based upon the backend for front-end framework. So what is the backend for front-end framework? Sorry. If you look at all these devices and you think about it, they all provide you different experiences. So your iPhone might show you, when you look for titles, you will see 2 titles, 2 per row, and then maybe 4 rows. A TV will show you maybe 5 to 6 titles per row, then 4 to 5 rows. So they have completely different experiences. And the client teams want to provide you the best experiences possible. So they will want to tailor the requests that they're doing to get the data to their experience. So instead of, you can't do that with a one-size-fits-all API. They need to be able to get the exact data that they need and not more. So that's why we have those backends for front-end. Instead of calling one API that everyone uses, they can define their own APIs. So in the end, they operate a backend service for each of their own client. And that's what we call nano services. So we have that backend for front-end framework. But typically, client teams, they want to focus on feature development. They're interested in getting new features out in their client. They'll have to write their APIs, but then they want to iterate quickly and move features to production in the app. They're not so much interested in what's required for orchestration, set up their infrastructure, make sure everything's provisioned correctly. That's not their core concern. And that's why, so we provide, with that platform, we provide the orchestration. All the pipelines are defined by us, and they don't need to care about that. And the centralized operations team handles the operations for them. So not just the operations, but also the deployments. They need to make sure that everything's provisioned correctly. So to recap, when you look at the software development lifecycle, this is a simplified view of the aspects we are mostly interested in. The full cycle developers cover the whole SDLC, while the centralized operations team is mostly focused on the latter part, the deploy and operate. And just for completeness, I added also client developers, which are mostly care about developing feature and testing them, making sure everything is fine. So what challenges did we encounter along the way with these two models? So first, let's take a step back. You joining Netflix, you joined the Edge engineering team, and you want to develop your first service and push it out to production. So you start coding, and this is my photo for coding. I picked this one because it could look like one of my Spinnaker expressions. And so you start coding, your code is ready. Now you want to push it to production. So first you test it, it's ready, you want to push it out to production. So that's when you create your Spinnaker pipelines. And because we're talking about Spinnaker, I had to put a photo of a sailboat. Unfortunately, it doesn't have a Spinnaker, but pick this one because it's in Seattle, and you might have noticed that we're actually in this building. So you have your pipelines in place. You can keep iterating on your app. You find bugs, you fix them, or you add new features, and you can roll them out quickly thanks to your CI/CD setup in Spinnaker. And now fast forward 6 months from now, you want to add a second or third service or even more. And so you will have to manage multiple services and multiple pipelines, and this is when your headaches start. So currently, there's no first-class way in Spinnaker to take an app, take all its pipelines, and clone it, and have all these pipelines in a second app. The way to do it right now is you go to your first app, you edit your pipeline, you copy the JSON, you go in your new app, you create your pipeline, you paste your JSON. So you can wrap tooling around this, but it's not very convenient. And that's for the easy case. The more complicated cases, you have a pipeline that executes another pipeline. And in the JSON, this pipeline is referenced by ID. It's not referenced by name. So when you copy it and you want to paste it, you need to make sure that the pipeline ID reflects the new pipeline in your new application. And then it's a big headache because you need to make sure of the order in which you create your pipelines. And now I'm just talking about one pipeline into maybe 2 or 3 apps. Now imagine you have 5 applications and you have 16 pipelines. That's not going to be a lot of fun. So that's one of the bigger concerns we had. So we had slightly different sets of issues with challenges with the 2 operations models. For full cycle developers, because the teams deal with all the orchestration and all the infrastructure, and they deal with a lot of services, the biggest challenge for them was the toil of managing pipelines. If you have 2, maybe 3 applications, might not be too bad, but when you start getting more and more services, then it's a big toll on teams to keep maintaining those pipelines. And then eventually, it might lead to drifts over time between services. Let's say you have a new instance type coming out, new AWS instance type, then you need to change all your deploy pipelines to use that new instance type because it's cheaper and it's faster, it's more powerful. And then you change in your first app, your second app, but you forgot in your third app. So eventually, you'll start seeing drifts in your pipelines. And then as a result of that, you will not see best practices used consistently across services because you might add best practices in most of your apps, but again, you forget it in one app, and then you don't have your best practice in place. For instance, you would not want someone to push to production on a Friday at 6 p.m. when everyone's at happy hour. That might not be great. On the centralized operations side, you have we had a slightly different set of challenges. The upside that we had is we provided the platform and we provided the orchestration. And we were only dealing with a small set of pipelines, about a handful. So that makes things easier. But we still run into a problem that pipelines need to be cloned across applications. So we get back to the same problem that I mentioned earlier. You get your pipelines, you get a new service on board, and you need to make sure that this service also gets a new pipeline, so we need to clone them. So again, we can use tooling, but it's a little inconvenient. And then that platform is still in active development, and we're onboarding new teams on it. So we find issues along the way in our pipelines, and we need to fix them. Or we need to add new features. For instance, a few months back, we added auto-scaling support to our containers. And we needed to get that rollout to every single application. And when you're talking about dozens of applications, you want to make sure that everyone gets that update. And that's when managed pipeline templates came to the rescue. So we're fairly early adopters of MPT within Netflix. And luckily, the Spinnaker team helped us a lot deal with, or helped us a lot go on to managed pipeline templates and make it so that we could implement our use cases. And you can ask Rob Zinnert, he'll tell you that I bugged him quite a lot. So what do you get with managed pipeline templates? First and foremost, you can define your templates just once and reuse them across all your applications. So instead of having one deploy pipeline that you are going to have to clone and in 5 applications, that means you have to manage five pipelines which are essentially the same, but there are different JSON blobs in different applications. Now you have one single template that you can use in these 5 applications. So that central place will be used in all these pipelines. So when you do a change in your template, all applications will get the benefits of it. There's also a handy CLI to convert your existing pipelines into templates if you want to use that. You don't have to create your templates from scratch. You can use your current pipelines and just convert them into templates. You'll get a YAML file, which is what templates are defined in. There are concepts of inheritance, modules, and partials. Inheritance is pretty straightforward. You can define a template, and that can another template can inherit from it, so it can use anything that is defined in that template. Modules, you can think of them like single stages that are parameterized and that you can use within templates. And partials are like sets of stages. I'm going to show you a quick example. I collapsed the code to hide a bit of the details because they're not so interesting, but at the top you can see a partial which defines 3 stages, which is configuring the auto-scaling metrics, which is forwarding to CloudWatch, and then it creates two scaling policies, a target tracking for scaling up and a step scaling for scaling down. And at the bottom, you see those modules, which are basically the single stages that we define. So deploying a cluster, creating that metric forwarding to CloudWatch, target tracking, and step scaling. As you can see, in that partial, we reference the module that we defined below, create metric forwarding. There's also a more advanced way to have conditional stages. So you might be familiar with having conditional stages where you define an expression and then the execution is skipped, but you still see that stage in the graph. With managed pipeline templates, you can actually have that stage completely removed out of the graph. So when you have complex pipelines or very big pipelines, then it makes it easier to reason about the whole pipeline execution if you remove the stages that are not relevant to that execution. You can also use variables, optionally typed, so it's kind of like parameters, but they mostly come into place with modules and partials. And you also get a very powerful expressions language, which is Jinja. You can do, so I'll show you an example a little later, but you can craft really, really complex pipelines with that. And now we'll do a demo. So here's a simple application. You want to deploy, deploying a service to production. It has nothing fancy, just one stage deployed to US East 1. But now, let's say we want to add auto-scaling to that pipeline. So we're going to go in the template YAML. This is the template I showed you earlier, a little snippet of it. The auto-scaling is commented out. So we're going to enable the auto-scaling in the template, commented in, and now we're going to publish that template. So we wrote a handy little CLI tool to publish the template. Hit enter, and we're going to publish it. And you can see it's already published to Spinnaker, and now it's available to all applications that are using that, referencing that template ID. So now let's go back to Spinnaker, reload the pipeline. And now you can see that we added those three auto-scaling stages, so creating the metric forwarding and the scaling policies. But now we want to do a little more. Right now, we don't have any restriction time windows for deployment, and we want to add that best practice. So we're going to go back to the template in a second. And we're going to uncomment that restriction time windows and set it from 10 a.m. to 2 p.m., which is before peak in US East 1. So we save the template, we publish it to Spinnaker, and again, it's fairly quick. Now it's published, we can go back to our application, we reload the pipeline, and now you can see shortly that we have the time restriction window enabled for this pipeline, which is from 10 a.m. to 2 p.m. on weekdays. So what did we learn on our journey to using managed pipeline templates? We got a lot of benefits from them. Going back to what I said earlier and the challenges that we faced, we have now fewer pipeline implementations to maintain. So the toil of managing pipeline is drastically reduced. Instead of having, again, let's say 10 different pipelines that are technically the same, but they're different JSON blobs, now you just have one single template and you reuse it across your 10 applications. Now pipeline are also consistent across services because if they all reference that one template, as soon as you publish your template, then it's available to all the applications, and there's no drift anymore. And as a result of that, you can reuse your best practices across multiple applications. It's much easier to use best practices across multiple services and across multiple teams because we can put them in those central places and everyone uses them. So we can add those restriction windows, or we can add those this auto-scaling, And we can also define common workflows. We have a canary analysis template, or you have a CI template, and they can be reused across different teams, rather than having every team define their own templates, their own pipelines. Again, very powerful expression languages. You can combine, so you get Jinja with managed pipeline templates, but you can also combine that with a Spring expression language from Spinnaker. And if you combine both, you can have very, very powerful and very complex and dynamic pipelines. Again, I'll show you an example shortly. That helped us solve a lot of our use cases. Also get better collaboration on pipeline templates. So for that platform that I mentioned, we started that original set of pipelines for the platform that the client teams are using. But the team that is operating that platform also contributed to adding features to the pipeline templates, also figuring out bugs and fixing them, because we had that one central place where everyone could work on a pipeline template, and then we could roll it out to users. Whoops, too fast. And as you could see earlier from the demo, the great thing you get with that, it's very easy and very fast to roll out your changes. So you want to test out a fix, or push out a fix, or add a new feature quickly, you just publish your template and it's available to everyone. And on the flip side of that, if you break something for some reason, then you can quickly roll back and unblock everyone. But of course, it wasn't all rosy. We also came across a few shortcomings along the way. So there's no first-class notion of versioning or status type. What I mean by that is that there's no revisioning. When you publish a template, you overwrite your previous version, and you can go back, but you can't go back as a first-class thing in Spinnaker. Or there's no status type. You don't have the notion of snapshot or candidate or release. So what we did for that is that we built custom versioning in the template ID. So we have tooling and orchestration that will notice that there's a change in the pipeline, and we can rev up the patch version, and we go to all the applications and change the version that is the suffix to that pipeline ID. You can see here, the pipeline ID is Spinnaker Summit 102. If you need it, you have your patch for that. We have the tooling and orchestration in place that will go in all these pipeline configurations and will change the ID from 102 to 103. And then these pipelines will get that update. Another shortcoming was that there is no first-class notion for configuration overrides. What do I mean by that? It's a little more complicated. So you have two apps. They do different things. One is just basically, let's say it's just a cache, and the other thing is doing very compute-intensive workloads. So you can reuse the same template, but inherently they won't have the same requirements. The first app might just need 10 instances and is fine with 2 CPUs. The second app needs 100 instances and 8 CPUs. And you can't put that in your template because everyone gets it. So you have to put in your pipeline configuration. But then we had the extra use case that we wanted to say, we provide defaults that you can use, or you can specify your own overrides. But we wanted to say also, if you need to change something at runtime, say you want to deploy, you specified 100 instances, but you want to deploy 150 instances for some reason, then we want you to be able to do that. And how that looks like is, we built custom overrides as variables in pipeline configuration. So that looks like this. So this is an expression to get the number of instances. So as you can see, we first look at the trigger parameters of a parameter called instances. If that is defined, we will use that value. Otherwise, we'll take a look at the resource overrides that you defined for your app, and we'll use that instead. And if you didn't specify anything, so you didn't pass in instances as a parameter or define overrides, then you will use the defaults that we provide in the template. And how that looks like in a pipeline config is something like this, where you define your variables, and you can create your resource overrides and say exactly what you want. Here's the instance count and the CPU count. So one of the tricky things with MPT was that, while it's very powerful, it's also harder to debug. So I mentioned you have the ability to combine Jinja and SPEL, and it's great. You can do very complex pipelines and solve a lot of your use cases, but they are also very hard to read. And spotting errors in those expressions can be very tricky. It almost looks like the code I showed you earlier for when you were developing an application. So we had cases where we were missing a bracket somewhere, and it was really hard to spot where. And sometimes when you combine Jinja and SPEL, the validation in some cases didn't work, or it validated the pipeline, but the pipeline was in fact broken. And it took us a while to figure out where exactly the bracket was missing. So error messages were not always helpful, more specifically in that one case where we had an error and it told us the template was invalid, but we had a hard time finding where exactly in the template, where in the change the error was wrong. And now you're not dealing with pipelines as JSON. You can go, if you need to change something and test it quickly, you can just go in the pipeline, add a stage in the UI, or edit the JSON. You now have to go to your template definition and publish it, and make sure that you need to be aware that when you publish it, it gets available to everyone. So which brings me to the next, So first, this is one of the expressions of a combines Jinja and SPEL expression. This one is not too bad. This is just to resolve a server group name that we can use to create the auto-scaling configs. And I have way worse expressions, but I'm not going to show them today. So testing is tricky. Again, as mentioned, you can, when you publish a template, it's available to everyone. You override the previous version. So you need to be aware that you can break things. So make sure you put a good testing methodology in place. Ideally, you'll have some orchestration that will look at, ideally you have your templates in Git, somewhere in version control, so you can roll back to a previous known version, and you have orchestration in place that will, on a Git trigger, will take the template, push it out, change its template ID, push it out to something like -snapshot, and you have integration tests in place that run against those snapshot templates and that can verify that your pipeline executions are still fine. So we have such integration tests, and when we see one of these tests breaking, the pipeline is not running, then we can see that we broke something. And again, when you push something, everyone gets the update. So if you are doing critical changes, think about a strategy for slow rollouts. One of the things we did was adding the versioning, where we could slowly change the version for a few apps, and if we noticed that we didn't break anyone, then we could just ramp up the adoption for everyone. And same thing, make sure that if all your tests for some reason don't catch errors that you introduced with your new template version, then make sure you have a good way to roll back, that you can go back to a previous version, hopefully in source control or some other way, but you need to be able to unblock your users quickly. And finally, be aware that you can break everyone and make people very angry because their pipelines are no longer working. So this has rarely happened, but very occasionally we've broken some templates and it blocked some users. Luckily not that long because we were able to roll back quickly. We were able to detect the problem quickly, and even though some users were trying to run it at the same time as we detected the problem, we could do a quick rollback and unblock everyone. So they didn't come at us with a punisher. So overall, the benefits we got from managed pipeline templates greatly outweigh the shortcomings that we found along the way. And the Spinnaker team was very helpful in getting us to put all our use cases in place. So we're very excited to see where managed pipeline templates are going to go. Very excited about the declarative Spinnaker that is coming, and tomorrow there will be a talk by the two Robs at 10:45, I think. So I highly encourage you to attend it. I'll be there. I hope you learned something today. that some of the experiences we had resonated with you. And on that note, thank you very much.